Exercise 2.2, Question 1, Part 6. Find the zeros of 3x squared minus x minus 4 and verify the relationship between the zeros and the coefficients. Step 1. Identify the coefficients. P of x equals 3x squared minus x minus 4. Here A equals 3, B equals -1, and C equals -4. Step 2. Factorize by splitting the middle term. We need two numbers whose sum equals -1 and whose product equals A times C, which is 3 times -4, equals -12. Testing the pair -4 and +3, -4, plus 3 equals -1 and -4 times 3 equals -12. Both conditions are met. Splitting, 3x squared minus x minus 4 equals 3x squared minus 4x plus 3x minus 4. Grouping x times 3x minus 4, plus 1 times 3x minus 4. Factoring out the common bracket gives x plus 1 times 3x minus 4. Step 3, Zeros. Setting each factor to 0, x plus 1 equals 0 gives alpha equals -1, and 3x minus 4 equals 0 gives beta equals 4/3. Step 4. The parabola y equals 3x squared minus x minus 4 opens upward and crosses the x-axis at -1 and at 4/3. Both crossings are visible on the graph. Step 5. Verify. Sum of zeros, -1 plus 4/3 equals -3/3. Plus 4/3 equals 1/3. Negative b over a equals -1/3 equals 1/3. Sum is verified. Product of zeros, -1 times 4/3 equals -4/3. C over a equals -4/3. Product is verified. All coefficient relationships are confirmed. Exercise 2.2, Question 2. Find a quadratic polynomial for each given pair of sum and product of zeros. The formula to use throughout this question is P of x equals x squared minus the sum of zeros times x, plus the product of zeros. This comes from the factored form and the coefficient relationships we studied. We simply substitute the given sum as s and the given product as p into x squared minus sx plus p. Part 1. The sum of zeros is 1/4 and the product is -1. Substituting into the formula, P of x equals x squared minus 1/4 x plus -1, which simplifies to x squared minus 1/4 x minus 1. To write it without fractions we can multiply throughout by 4 to get 4x squared minus x minus 4. Part 2. The sum of zeros is √2 and the product is 1/3. Substituting P of x equals x squared minus √2 times x plus 1/3. Multiplying by 3 gives 3x squared minus 3 √2x plus 1 as an equivalent polynomial. Part 3. The sum of zeros is 0 and the product is √5. When the sum of zeros is 0 there is no x term at all. Substituting P of x equals x squared minus 0 times x plus √5, which simplifies to x squared plus √5. Part 4. The sum of zeros is 1 and the product is 1. Substituting P of x equals x squared minus 1 times x plus 1, which gives x squared minus x plus 1. Part 5. The sum of zeros is 1/4 and the product is 1/4. Substituting P of x equals x squared minus 1/4 x plus 1/4. Multiplying by 4 gives 4x squared minus x plus 1 as an equivalent form. Part 6. The sum of zeros is 4 and the product is 1. Substituting, p of x equals x squared minus 4x plus 1. This cannot be factorized simply, so we leave it in this standard form. Let us review the key insight across all 6 parts. We are using the reverse direction of the coefficient relationships. Instead of going from polynomial to sum and product, we go from sum and product back to the polynomial. The formula x squared minus sx plus p is the universal tool for this. Always check your work by computing the sum and product from your constructed polynomial and verifying they match the given values.